Hello everyone, let us see next example of Fourier transform chapter 34th example. Find Fourier transform of the function. Function is given like fx is equal to, we have studied we are now studying Parseval's identity. We have seen lots of examples depend on the 6 Parseval's identity formulas. Now let us see next example depend on that. Here a normal question is find where to find Fourier transform of this function. Function is given fx is equal to, it is 1 minus mod x, where mod x less than 1, it is 0 for mod x greater than 1. But to first find out Fourier transform of this function, then depend on that answer we have to find out this. Hence show that we have to evaluate this integration, and answer for that is pi by 3. We have to show that. Okay, let us start with the Fourier transform. Fourier transform of any function fx is given by this formula. Fs, that is f of fx, is equal to integration minus infinity to plus infinity fx e raised to I sx dx, where a function is this. Okay, we have to put this formula function here. For that, mod x less than 1 means x lies between minus 1 to 1. For that, function value is 1 minus mod x, and it is 0 for any other value. That means minus 1 to 1, function value is 1 minus mod x. Otherwise means mod x less than greater than 1 means for values minus 1 to minus infinity and 1 to infinity, function value is 0. That's why this integration can be split into 3 integrations up to this first interval, then middle interval, and the last interval, in which 2 integrations are 0. That's why you don't need to write 0 integrations. Just write down the integration which is exist in this particular interval minus 1 to 1. That's why given interval can be converted into minus 1 to 1, and function value in this interval is 1 minus mod x e raised to I sx dx. Okay, now next step will be our regular we have studied how to find out Fourier transform of any functions. In that examples also we did this step, where in next step we have to put the e raised to I sx formula, that is e raised to I theta cos theta plus I sin theta. Theta is sx here, angle which is coefficient of I, that is cos sx plus I sin sx. This is the value of e raised to I sx. Okay, now multiply this bracket inside and separate out this integration. We get integration minus 1 to 1, 1 minus mod x into cos sx dx, plus I is a constant, take outside from the integration, 1 minus mod x into sin sx dx. Now we have to decide whether these functions are even or odd. We know mod x is a even function. Whatever the, if you put minus sign inside this mod minus x, it becomes plus x. That's why this is a even function. This functions remains as it is, because see, what is the definition for even function is, if f of minus x becomes f of x, it becomes even function. Or if f of minus x becomes, it is even, and f of minus x, if it is minus x minus f of x, then it is odd function. Okay, now here 1 minus mod x, if you replace x by minus x, suppose fx is equal to our 1 minus mod x, okay, into, if you take cos x also, that is also okay. If you put x instead of minus x everywhere in f of x, we get 1 minus mod of minus x, and we know mod of minus x is plus mod x, and this is the original function fx. That's why fx, this function, is a even function. Now cos x, we know this is a even, and sine is a odd function. Now multiplication of even into even is even, and multiplication of even into odd is odd function. Okay, that's why this integration becomes integration of minus a to plus a. This we already know the result. Integration minus a to plus a fx dx is 2 times integration middle number of minus a to any number minus a to plus a, middle number is obviously 0. fx dx if it is even function fx, and it is 0 if it is odd function. That's why using this result, this is odd, that's why minus 1 to 1 this integration becomes 0, and this is even, that's why minus 1 to 1 integration becomes 2 times 0 to upper limit 1 function as it is dx. Okay, now next step will be we have to remove this mod x. Now x integration is with respect to x, and x limits are 0 to 1. In 0 to 1 x is obviously positive numbers, all numbers are positive, that's why mod x becomes x only, because x is positive in the interval 0 to 1. Okay, now this integration is very easy. We can solve it by part method or u into v rule of multiplication rule of integrations. This is u as it is, integration of v cos sx integration is sin sx upon sx derivative with respect to x is divided, that is yes, minus next sign will be minus this in derivative of this function here, minus 1 is derivative here, into bracket this function's derivative here, where s is a constant, keep that as it is. Sine derivative is integration. Sine integration is minus cos sx upon sx derivative should be divided s, that s and this s becomes s square. Okay, now bracket complete. Next step will be plus minus 1's derivative is 0, that's why u into v rule ends here, limits are 0 to 1 as it is. Now if you put upper limit 1 here, we get 1 minus 1 0, and here minus 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 3 times minus becomes minus cos, instead of x we put upper limit 1 cos s upon s square, this is the upper limit, minus lower limit put bracket for lower limit 0, in sine 0 in x sine 0 becomes 0, and here minus 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 3 times minus becomes 1 time minus cos 0 is 1 upon s square as it is. Okay, now minus minus becomes plus, 2 upon take s square outside, this 1 take positive term first, minus cos x as it is. This is the answer for Fourier transform of this function. This is very easy. Okay, now we have to show that this integration 0 to infinity sin raised to 4t upon t raised to 4 dt is equal to pi by 3 using this result, where we have this Fourier transform of one function fx. We have fx and fs. Now we have to use, and sin raised to 4 higher order is there, sin raised to 4 upon t raised to 4 is there. That's why if sin square is there, 1 minus cos x easily converted into, we have already seen such type of examples in Fourier transform, where hence part of Fourier transform can be solved using inverse Fourier transform, but this particular example is not of that type, because sine power is higher, raised to 4, and t raised to 4 is there. Understand? If sine square upon t square is there, that example already we have studied or we have solved. But here sine raised to 4 upon t raised to 4 is there. Higher order of, higher indices of functions are there. That's why this part can be solved using Parseval's identity only. Because in Parseval's identity, here squares are there. Okay, function squares are there. That's why those terms, those functions will be coming to in higher order in a resultant step. That's why this example also can be solved by only Parseval's identity. And if you want to use Parseval's identity in this particular example, what we have only is a function and its Fourier transform fs. That's why we have to recognize that formula of Parseval's identity among 6 formulas, which formula contain fx and fs only. That is only one identity, first formula. Okay, that's why put this formula here, we are going to use this formula here. Now by Parseval's identity, this is the formula we are going to use. Put this values fs and fx here in this step, where we get 1 upon 2 pi integration minus infinity to plus infinity. Fs is this term as it is square, ds is equal to integration minus infinity to plus infinity fx. This fx, we are now a function is this, and function exists between -1 to 1 only. That's why this integration converted into -1 to 1. Fx is 1 minus mod x bracket square as it is, dx as it is. Okay, now again this 2 to the square, take outside, 2 4 upon 2 pi integration minus infinity to infinity 1 minus cos s bracket square as it is upon s raised to 4 ds. Okay, is equal to, now in this particular example, this is also, it is a even. Okay, mod x is greater than 0. Okay, that's why it is a even square. Obviously any number square is positive, that's why it is a even function. That's why we are going to use this result again here. It is 2 times 0 to 1, upper limit 1, this 1 minus, obviously this is a positive numbers in 0 to 1, everything is positive, that's why mod x becomes x only, bracket square square as it is, dx. Okay, now next step, here in the next step we are going to solve this integration. It is very easy, just expand these squares, and here this is the integration we want to solve. That's why here 1 minus cos is this there, and here sine raised to 4 is there, divided by s raised to 4 we already get here. But for that we are going to use the formula for sine square theta, that is 1 minus cos 2x by 2. Okay, that's why here, see what is the reason behind that. We know sine square x is 1 minus cos 2x by 2. That's why 1 minus cos 2x becomes 2 sine square x. And here we want 1 minus cos single angle, cos x only. That's why we have to convert this 1 minus double angle into 1 minus single angle everywhere, divided by 2, angle becomes half both sides, we get sine square x by 2. Okay, this is the result we are going to use here. That's why this is 2 gets cancelled, 2 upon pi outside, minus infinity to plus infinity 2, this is 2 sine square, variable is s by 2, bracket square as it is, divided by s raised to 4 as it is, ds. And RHS side, expand this a minus b bracket square as it is into dx. Now here take again 2 to the 4 outside of this integration, 4 into again 2 upon pi integration. See, now this 2 to the 4, take outside of this integration constant, we get 2 into 4 upon pi as it is, minus infinity plus infinity sine raised to, this becomes 4 s by 2 upon s raised to 4 ds. On RHS side, 2 as it is, bracket 1 integration is x integration x square by 2, x square is x cube by 3, the integration 0 to 1. Now again next solve this integration, 2, put upper limit here, instead of x replace 1, 1 minus this 2 gets cancel, 1 minus 1 again plus 1 by 3, minus lower limit becomes 0. Okay, this becomes 2 by 3, 1 gets cancelled, answer is 2 by 3 on RHS side. Now LHS side, this integration again, see 8 upon pi integration minus infinity to infinity sine raised to 4 s by 2 upon s raised to 4 ds. Okay, now in this integration again this is a even function because power is sine raised to 4 and sine raised to s raised to 4. That's why instead of s, if you replace minus s everywhere, it becomes similar, it becomes constant as it is. That's why it is a constant even term, and not constant, it is the even function. That's why again we are going to use this result. Which one? This result integration result, we get this integration 2 times. Middle value is take 8 upon pi on that side. We get this is again 2 gets cancelled. Resulted is pi by 12 here and 2 here. Okay. Okay, 2 times it becomes 2 times 0 to infinity. This as it is equal to this pi on comes to numerator and 8 comes to denominator, and which 2 2s are 2 4s are 8, 4 3s are 12. Okay, this integration becomes this. Now we can convert the take 2 on that side also in this step itself. Now concentrate on this integration. We get this integration and we want this integration. And what is the angle here? Single angle only. That's why, and we get here half angle. That's why next will be the substitution method of integration. We have to just make this angle single angle. That's why substitution must be put s by 2 is equal to other variable t. Put that variable which we want in our example, t. Okay, that's why put s by 2 here is equal to 2. Therefore s is equal to, take 2 on that side, 2t. ds is equal to 2 into dt. And limits we have to check limits becomes as it is, because if you lower limit of s is 0, upper limit is 0 of t, and if put lower upper limit infinity here, upper limit for t is also same. Okay, now put these values here. We get to take on that side, it becomes pi upon 24 integration 0 to infinity sine raised to 4 as it is, s by 2 becomes t, and divided by s is 2t raised to 4, and ds becomes 2 dt. Okay, now 2 2s are 2 into 2 into 2, it is 1 2 gets cancelled from this, 2 raised to 4, 2 raised to 3 remains, that is 1 by 8 take outside, sine raised to 4t upon t raised to 4 as it is dt, and is equal to pi upon 24. Take 8 upon that 8 on that side, we get integration 0 to infinity sine raised to 4t upon t raised to 4 dt is equal to pi, 8 comes to numerator, 8 pi by 24, that is pi upon 3. Okay, now consider next example. This is a homework for you. If function fx is equal to given by this 1 0 for mod x less than a, means x lies between, this is the it is like this, sorry, minus a less than x less than a. Okay, this is the meaning of this. And for mod x greater than a, it is 0, and fs is already given. Okay, fs means Fourier transform of this function is 2 sine as upon s. Now what we have to do? Prove that this function, this integration 0 to infinity function is sine square ax upon x square dx. Value of this is pi a upon 2. Okay, already function is given, fs is given. That's why here hint is use Parseval's identity, where fx and f of s is there, that is this one is only formula. Put these values here and solve the integration, you get this answer. Okay, okay, these are some examples depend on Parseval's identity. Now let us see next properties of Fourier transform. There are again some properties of Fourier and both Fourier sine and cosine transforms. Let us see first one. If f of s, these are notations we have to know. F of s x fx means Fourier sine transform of x into, if any function is there and multiplication x is there, then it is equal to minus d by ds. It is like Laplace transform of multiply by t property. Okay, minus d by ds means derivative of fcs means Fourier cosine transform, which where fcs is Fourier cosine transform of this function only. That means if you want to calculate Fourier sine transform of such functions, where x is there into some function, then just calculate Fourier cosine transform of this function and take derivative. Okay, this is the property. Again, this property is again same for Fourier cosine transform. Just replace s by c and c by s here, which is same for Fourier sine and cosine transform. Okay, now next consider the example depend on this. Find Fourier sine and cosine transform of the function x into e raised to minus ax. If you um, directly calculate the Fourier sine and cosine transform of x into e raised to minus x, it is quite difficult to calculate these integrations, to solve those integrations. That's why use these formulas here. Here x into one function is there, and this function is exponential, which is very easy to calculate the Fourier and sine and cosine transform of that function. Okay, let's start with let fx is equal to e raised to minus ax, this function, and now Fourier sine transform of x e raised to minus ax is given by these two formulas. Okay, we have to calculate one by one. First, find Fourier sine transform of fx is e raised to minus ax. FSS, that is Fourier sine transform of any function, is given by 0 to infinity integration fx sin sx dx. Put the value fx, that is e raised to minus ax here, sin sx dx, and this formula is e raised to minus ax upon a square minus a square is plus a square plus x s square angle square. This is a formula. Which formula is that? E raised to integration ax sin bx dx is e raised to x sin bx dx is e raised to x upon a square plus b square into a sin bx minus b cos bx, where a is exponential coefficient, whatever it is, plus or minus, and b is angles coefficient. That's why what is a here? What is a here? Here a is minus a, and b is x coefficient, that is x coefficient is yes here. Okay, using this formula, its answer is e raised to minus ax upon a square plus a square, a sin bx, that is minus a sin sx, minus b, that is yes cos sx. Now put the limits. Infinity in e raised to minus ax. In x we get e raised to minus infinity is 0, upper limit becomes 0, minus, put bracket for lower limit, 0 in x, 1 upon a square plus s square into bracket as it is, sin 0 is 0, cos 0 is 1, that's why it becomes only minus, yes, bracket complete, square bracket complete. My answer is minus minus becomes plus, s upon a square plus a square. And also we want this also, that's why similarly calculate Fourier cosine transform of this function like this. Answer is similar way. Answer is a upon a square plus a square. Now we have to put this values here. Therefore, from 1, call this formula as 1, call this formula as 2. From 1, Fourier sine transform of x into e raised to minus x becomes minus d by ds. Fourier cosine transform of e raised to minus ax, that is a upon a square plus a square. Okay, take a constant outside. D by ds means derivative of 1 upon a square plus a square is minus 1 upon x derivative can be applied here, minus 1 upon a square plus a square bracket square into multiply the by chain rule bracket derivative, that is 2s. Minus minus become plus, answer is 2as upon this bracket square. Also from equation number 2, formula number 2, Fourier cosine transform of x into e raised to minus becomes minus d by ds of Fourier sine transform of this function, that is we have calculated as s upon a square plus a square. Now integration and derivatives with respect to s, that's why we have to use u by v rule here. V into derivative of s is 1 minus u into derivative of denominator is 2s divided by v square. Okay, now simplify s square plus a square minus 2s square becomes denominator is same, so s square minus 2s square becomes minus a square plus s a square divided by denominator same. Take minus inside, we get s square minus a square upon this bracket square. Okay, this is the Fourier sine and cosine transform using multiply by x rule. of Fourier sine and cosine transform. This is a property of Fourier sine and cosine transform here. Next, consider find example. Find Fourier cosine transform of e raised to minus x square and hence evaluate Fourier sine transform of x into e raised to minus x square. Okay, we have to find out what Fourier cosine transform of this first. Let us see first. Already we have calculated in example number 18 earlier. We have solved this example in example number 18. Okay, follow those steps as it is. Don't write in assignment from example number 18. Copy those steps as it is. We get Fourier cosine transform of e raised to minus x square is FCS is equal to root pi by 2 e raised to minus s square by 4. This is the answer for Fourier cosine transform. And what is hence part is comes from this. Evaluate Fourier sine transform of this function. That's why we know formula. Fourier sine transform of x into this function becomes minus d by ds Fourier cosine transform of e raised to minus x square. This is the formula. That's why what is Fourier cosine transform? This is we already calculated earlier. That's why put this value here. Now take root pi by 2 outside of this derivative because it is constant, and e raised to minus s square by 4 derivative is exponential derivative, that is exponential only. E raised to minus s square by 4 into derivative of indice should be multiplied, that is minus s square derivative is 2s. 4 is constant as it is. That's why answer for it this is 2 to the 4 root minus root pi by this becomes minus minus plus root pi upon this 2 to the 4. Again 2 gets cancelled, 4 take outside, s into e raised to minus s square by 4. Okay. Okay, let us see. This is the homework for you. Find Fourier cosine transform of function fx is equal to, it is given, it is very easy example, finding Fourier cosine transform. Okay, it is given in the interval format. In 0 to 1 function value is x, in 1 to 2 function value is 2 minus x. For x greater than 2 means 2 to infinity function value is 0. That's why Fourier cosine transform integration 0 to infinity split into 3 integrations, and you have to calculate those integration by using bipart rule, and answer for those this question is this. Okay, just tell you that this is the homework for you. Okay, now next example is solve the integral equation. This is the equation given 0 to infinity f of theta cos alpha theta d theta is equal to limits. It is given in the interval format 1 minus alpha, it is 0 when 1 minus alpha is between 0 to 1, and it is 0 for alpha greater than 1. Okay, now we have to understand first what is the meaning of this question. Okay, if you solve any equation like for example x plus y is equal to 0, x minus y is equal to 1, suppose if you want to solve this equation, means what, we have to find out value of x and value of y. Okay, finding out variables value in the particular equations is called as solving the given equations. If suppose x square plus 1 is equal to 0, solve this integration means finding out variable value, that is x value. Okay, that is plus minus I. Well, answer for this. That means, but here this is not a simple equation, this is the integral equation which is given in integration format. And answer for this integration is one more another function in alpha. Okay, alpha is not a constant, alpha is variable because it lies between 0 to 1. Okay, and here in RHS side, solving the integral equation means finding out the function value. Okay, what is the unknown here? Cos is not unknown, f of theta function is unknown, we don't know what is f of theta here. Okay, that means solving the given integral equation means finding out the function, okay, which present in the integration f of theta. That means solving above equations means finding the value of the function f of theta. Okay, now for our convenience, obviously in throughout the equation, throughout the chapter, we know only x variable and s variable. Okay, that's why for our convenience on LHS side we replace theta by x and RHS side alpha by s. Okay, for our convenience only, replacing theta is equal to x and alpha is equal to s. These are dummy variables just for our convenience. In the last step we are just substituting alpha and theta. Now by replacing these, theta is equal to x everywhere and alpha is equal to s everywhere, we get this equation. Okay, integration 0 to infinity fx cos sx dx is equal to integration, this is the interval 1 minus s 0 to 1 for 0 to 1, and it is 0 for s greater than 1. Okay, now to solve this integration means just observe this integration. What is this? This is the formula for Fourier cosine transform of this function. Okay, we know Fourier cosine transform of fx is given by this function. This formula is for Fourier cosine transform. If you observe, these two are same. Okay, call this equation number 2, call this equation number 1. Now we know, comparing 1 and 2, above integration in 1, this is nothing but Fourier cosine transform of the function. Okay, now to find out, this is, we know this is we don't Fourier we don't need to calculate Fourier cosine transform, because already Fourier cosine transform is this and its value is this. Already this is the answer for Fourier cosine transform. Okay, now what is our motto? To find out fx, and we know if we know Fourier cosine transform and if you find out Fourier given function, we use inverse Fourier cosine transform. Okay, that's why we use that logic here. To find fx, we use inverse Fourier cosine transform formula. What is that? Fx is equal to 2 upon pi integration 0 to infinity fcs Fourier cosine transform cos sx ds. This is the formula for Fourier cosine transform. Or we want fx from fcs, that's why we use this inverse cosine transform. This is our formula. Now put this value here, 2 upon pi. Now fcs is this is this. Now therefore fcs is this. fcs is given by interval format. 0 to infinity can be split into, this is the number line. Okay, infinity. 0 to 1 function value is 1 minus s, and for 1 to infinity greater than 1 function value is 0. That's why fcs, that is this function, in 0 to 1 is 1 minus s cos sx ds, plus in 1 to infinity value is 0. You don't need to write, you can skip this step also. Okay, therefore this integration becomes 0, and this integration we can solve it by part or u into v rule of integration. U into integration of cos is sin sx upon derivative of sx with respect to s. X is constant now, should be divided, that is x, minus, second term will be minus its derivative here, derivative of minus s is minus 1, into sine derivative is minus cos sx upon x, and already x is there, that's why it becomes x square. Next term will be 0 because minus 1 derivative is 0. By part rule ends here. Bracket complete, square bracket complete, limits are 0 to 1. Now put limit 1 in yes, we get 1 minus 1 0 here, and here minus minus minus, because 3 times minus becomes 1 time minus. Instead of in yes we put 1, we get cos minus cos x upon x square. Now it is upper limit minus lower limit, put the bracket, 0 in sine 0 becomes 0, and this minus 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 becomes 1 time minus, cos 0 is 1 upon x square as it is. Okay, this is the answer for fx. This is our required answer. Now simplify, minus minus, take x square outside, 2 upon pi x square, takes minus minus plus 1, take positive term first, 1 minus cos x. This is the required answer for our question. We want to find out value of f of theta, but we replace this formula, replace this variable. Therefore at the end replace x is equal to theta. Everywhere we get f of theta is equal to 2 into 1 minus cos theta upon pi theta square. Okay, we use the reverse formula. Okay, that means finding out, solving the integral equations means you have to first recognize which Fourier transform is this. Here cos, that's why it is a Fourier cosine transform, that's why we use inverse Fourier cosine transform. If it is sine is there, we can use Fourier sine transform logic or method, and to find out f of theta we need for inverse Fourier sine transform in case instead of cos sine is there. Okay, here some for homeworks for you. Solve the integral equation. Similar type of example is there. Okay, now here t is there, replace, but here sine is there, that's why it is in Fourier sine transform formula. And f of x, instead of x is there, but instead of yes t is there, that's why replace t is equal to yes everywhere, so that we can convert those into our usual notation. Answer for this is this. Okay, solve using earlier example. Now show that the integral equation, solve the integral equation this. Okay, now here also replace alpha is equal to yes. Okay, the answer for this is, here cos alpha is there, that's why earlier example is similar, exactly similar to this. You use inverse Fourier cosine transform to find out fx. Answer for this is 2 upon, that is fx value. Here fx is equal to this, here also fx is equal to this, here also okay. This is the, these are two examples depend on the earlier example. Now last homework for you is find Fourier cosine transform of this function. We have already solved this in earlier example. Okay, where, see here, Fourier cosine transform of e raised to minus ax is like this. We already studied this. Just okay, copy this example as it is here. First example is, first question is finding out Fourier cosine transform, full stop. Hence evaluate this. Okay, what is the procedure to find out the integration using Fourier cosine transform? Already we have calculated Fourier cosine transform, and we know hence part of Fourier cosine transform can be solved by inverse, using inverse Fourier cosine transform. That's why we have already studied such examples. Okay, go through that. Therefore use inverse cosine transform to find out the integration. Okay, answer for first question is this, answer for this question is this. Okay.